Hello and welcome. Today I would like to present the Alphabetifier. It's a simple production with a huge impact. The Alphabetifier is a device that aims to assist children to play and enjoy mathematics as well as spelling. It is also aimed to assist children with learning disabilities such as dyslexia. Our team is composed of 4 second-year electrical engineering students, and we're excited to present today our idea for production. Our first and main component is the microcontroller. The microcontroller that we're currently using is the Arduino Uno, which runs off the Atmega 328P. It runs off the Arduino IDE, which is coded using the processing language, which is a wraparound Java. It also has a 16 MHz CPU, as well as a 2 KB SRAM and a 32 KB flash. It has 26 input-output ports. Another option that we have considered is the PIC16F, which runs off the C language, is a 32 MHz to 31 kHz. It has 2 KB SRAM as well as 28 KB flash memory, and it has 28 input-output ports. A third and final option is the ARM STM32F, which runs off the MicroPython. It has 168 MHz as well as 192 KB SRAM and 1 MB flash, and has up to 140 input-output ports. I have developed code to run with all 3 of these, but we have currently decided to use the Arduino Uno because it is currently the easiest one to use. Another important component is the SD card and SD card reader. We have decided to use the Adafruit 5V micro SD breakup board because it uses 3 to 4 digital pins to read and write 2 GB plus of storage. Currently we are using a micro SD card that has 16 GB of storage. It also has a 3V level shifting, which means it can run with devices that either has a 3V or 5V output. It also has an activity LED, which lights up when the SD card is being read or is being written into. We have developed our own dual bypass filter and amplifier, which is determined by the schematic below. The full circuit schematic can be sent out to producers to allow them to be able to produce the device that we want, and it will be easier for them to follow the proper documentation. We have also designed a PCB design using the Eagle software. It's a 5.418 inches by 3.608 inches, and this can also be sent out to producers to be able to produce the device that we need. All the important user components are on the top, such as the button and the LCD, and all the components that are not necessary but important for the device such as the Arduino and the capacitors and the resistors are on the bottom layer of the PCB. PCB layout has determined that it can give us the device for 97.74 per unit price, and they can produce it in only 5 to 10 days. The code in which the device is currently running will be kept with us, and it does not have to be changed to be able to add more questions. The questions can be coded or added onto the SD card, and as long as the proper format, which is determined in the text file in the SD card, is followed, then the code will work as is. Thank you, and we look for future cooperation.